in example 2, it's asked for the next 3 terms of this sequence. But it had to give the first 2, and it's told us that the first 2 are 1 and 2. So that means we know U1 is 1 and U2 is 2. And it's asking us to find the next 3. So that would be asking for U3, U4, and U5. To find U3, we would use this formula. And it's referring to 2 lots of the term before it. In this case, the term before it is 2. So it's 2 lots of the term before it, plus 1 lot of the term before that, which is 1. And this is 5. This, to find U4, we could replace the n's with 4's here. So it's actually saying 2 U3's, replacing the n with a 4 gives you 3 here. And then replacing this n with a 4 gives you 2. So that would be plus U2. And then we can just refer to our previous numbers. So it's 2 lots of U3, which is 10, plus U2, which is 2, and that is 12. U5 is going to be 2 lots of U4 plus U3. And 2 lots of U4 will be 24, plus U3 is 5, so this is 29. Now remember, you can't leave your answers like this. You have to write your answers in a box. So if it's asked for the next 3 terms, you have to write 5, 12, and 29, and box that to make it clear that that is your answer. Now for example 3, it's given this sequence, and it's asked for the next 2 terms. So to go from the 6 to the 12, and then the 12 to the 24, and then the 24 to the 48, and the 48 to the 96, we may spot that what we're doing every time is just multiplying it by 2. So that is times by 2, we can multiply that by 2, and then we multiply that by 2 to get this term, and then multiply that by 2 to get that term, multiply that by 2 to get that term. And this one is a little trickier to find a formula for, but really it's quite simple when you know the trick. If I told you that you started with the number 1, and you double that, you get 2, you double that, you get 4, double that, you get 8, and 16, and so on. What do we notice about these terms? Well, these are just powers of 2. This is 2 to the power of 1, this is 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, and 1 is 2 to the power of 0. So all of these terms are 2 to the power of n. Well, actually, if this is the first term here, then actually all of the terms would be 2 to the power of n minus 1, because I want the first term to be 2 to the 0. So if the first term is when n is 1, then to make the first term 2 to the 0, I need to make it 2 to the power of n minus 1. So this refers to these numbers here. But what about the numbers I've got here? Well, that means that I've just looked at each one of these terms that I've got in this sequence, and I've multiplied every one of them by 6. So this is multiplied by 6. This is multiplied by 6. This is multiplied by 6. And so on. So it's just 6 of these. And that has to be written like this. It's 6 lots of 2 to the n minus 1. Now, why could I not write 12 to the n minus 1? Because if I tried to actually work that out and put n as 1 for the first term, then that would be 12 to the power of 0, which is 1, and that isn't 1. And in fact, this doesn't work. So index laws don't allow this to happen. These are not equal. I could only multiply these together if they had the same index. But because they don't, they have different indices, I can't just multiply these together. So the answer is simply this here. It's 6 times 2 to the power of n minus 1. But notice I haven't actually answered part A yet. Typical. What I should do is write out what that is. So for part A, the next two terms would be 96 times 2, and then the answer of that times 2. So 96 times 2 is 192, and then 192 times 2 is 384. And then, of course, I'd have to answer part B, which I have done here. So that is 6, 2 to the